Welcome. We'll continue. Last class was a marathon class, very important class. Hope you have gone through it. Okay, now, don't see this side. Never see this side now. Start from here. See, start here. Here start. Pin jointed plane frames with the two hinged support. Hinged or pinned. I will use the word hinge only. Two hinged support. Two hinged supports with only one member connected to one of the hinges and no member connecting the two hinges. This is a special type, remember. You make a note here, this is a special type. Special type. See correctly. For thoroughly understanding, refer question 26 and 27. One question, it was going up from supports. Other question, it is going to one horizontal vertical. Or this looks like a cantilever. This is not like cantilever. This looks like somewhat a vertical cantilever. You can tell that way. Okay, now, don't bother about those things. Pin jointed plane frame. See, actually one thing forgotten here. Actually, see, I will put little later. Then it will be more clear. Pin jointed plane frames with the two hinged supports. See here. Two hinges. Here, where are the hinges? Doubt comes. Wait 1 minute. Right now, refer 26. Later 27. See. With only one member connected to one of the hinges. Yes. Don't by heart A, B, C, D. See, to this hinge, only one member connected. This hinge, no problem. Only one member connected. And no member connecting the two hinges. See, there is no member there. No member here. Now see, come here. See, this, make a note here. Usually, some special note you are right. See, I will dictate only once. I decided now. I will later stages when this question comes, I will tell, go back and refer the starting class. When I give introduction, if you cannot refer there, study thoroughly and come here and ask me, what is, no, you can't come to and ask me. I am not responsible. See, in beam question, make a note here. If something given like this, we call it cantilever. This is a fixed support. Fixed support. Which can what? Offer vertical reaction, horizontal reaction and reacting moment. This is the fixed support for a beam. But remember, in pin jointed frame, support moment cannot come. Bending you are not considering. Only axial forces. So, if they give the question like this, then it is, see, right here, then it is understood. Understood. I will tell only once. I will not tell once again. You go through this class again and again. Okay, understood that this A is not a fixed support. I have seen so many places, they tell fixed at A. What is that common sense? It is not fixed at A. Even if they give this way, it is see, hinged at A. This also hinge. And see, this is not a member. Remember, make a note here. In the initially not given, write the sketch once. See, now do one thing. This sketch you write once again. At that time you do one thing. See, you write once again this member. See, I'll tell how to write. You after this one write the question once again. See, sufficient. Little more if you want. Okay. This way right here. See, there is no member here. See, no member here. No member here. Or now both are same. See here, two hinged support. Only one member connected to one of the hinges. Yes, here I maintain the same. Actually, for both of them, answer is same. This is nothing but same frame turned. Just to understand, see, only one member, you write here, upper frame. Through the hinge, right hinge, don't by heart A, B, C, D, right hinge. It can interchange. One of the hinges, see finger here, only one member. One of the hinges, only one member. And the two hinges are not connected. Two hinges are not connected. See, not connected by a member. Okay. Now, naturally, doubt comes. One, is it perfect frame or imperfect frame? See, perfect frame, n should be equal to 2j minus 3. Imperfect frame, n is not equal to j minus 3. And if imperfect, again doubt, deficient or redundant. If n is less than 2j minus 3, it is actually unstable. Remember, deficient, then it is unstable also. Remember, it is unstable. That is overstable. If n is, this all I told earlier, go back to introduction class and come back. If n is less than 2j minus 3, deficient frame, shortage is there. If n is more than 2j minus 3, excess is there, redundant. And last doubt also, stable or unstable, these questions. This is special, two hinges, stay unstable. Then most important, statically determinate or indeterminate. 100% determinate. Why? These questions are given for first semester BE in engineering mechanics, usually in first semester BE. In some colleges, third semester BE in structural analysis of pin-jointed frame by method of joints and method of sections. When it is given there, it should be determinate. Why? What is indeterminate, you study in the end. Okay, if it is indeterminate, one more chapter comes later. Analysis of statically indeterminate pin-jointed frame are called redundant frames, where you require either strain energy method. So it is called, you remove a redundant part, one redundant force you remove, then find forces 1 or 2, how many redundants are there, remove it, find forces in all members, sigma, that is called P, introduce unit force in place of redundant, say one redundant, K, sigma PKL by AE by sigma K square L by AE, which will give the redundant force, then force in any member equal to P plus KX or sometimes people tell either X or KR. Okay. That all comes in structural analysis, indeterminate frame. So, one more thing, right now I am conducting course for engineering mechanics. In engineering mechanics, indeterminate cannot come. Only determinate. Why? You should be able to solve using equilibrium. In mechanics, you are considering equilibrium. If you cannot solve using equilibrium, how you can, it becomes determinate? It is indeterminate. It should come in the higher semester. Usually, usually it comes in full study, see, moment distribution method, slope reflection method, Carney's method, higher, last, final year it comes. So therefore, but that you cannot give the answer. If somebody will question you, determinate or indeterminate, you can't tell, sir, this question usually comes in engineering mechanics, such questions. So since it comes in engineering mechanics, determinate. They will not agree. Okay, that you write. Now, I will explain only once. I decided not to keep on telling same thing again and again, because most of the people, academic point of view, I will tell the procedure. Competitive exam point of view also, I will tell the procedure. Those who want to learn the subject, they need some explanation. Explanation is for those who want to understand or all these things, they want a clarification. Okay. Now I removed everything. I decided, because this is so many of the people who are studying for engineering mechanics in first semester, if they go through all this, it will be confusion for them. So I will advise them, today's end of, see, these two questions I am solving next class, not this class. I will solve next class. But I want these questions so that what all I tell you understand. So, end of this class, I will write here procedure. You stick to the procedure, sufficient. Those who want even competitive examination also same thing. But there, some principles are there. So better go through. And those who want structural knowledge, go through everything. See, refer either question 26 or question 27. See, now, one more thing I have to do. See, actually these are all pin joints, understood. You write one modified sketch here. Write a modified sketch here. This also modify. There you show, see, joints are pins. This is support pin. Okay, now, see. Any question? Number of members. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I already told you earlier what is N and J. Somebody will ask, sir, what is N? Sorry. If you study the introduction class 1, first class 1 and class 2, then come here, it will be clear. If you have no patience to go to the introduction class where I told determinate, indeterminate, then what? Perfect, imperfect, deficient or redundant, stable, unstable, I told. If you have no patience for that one, then you take care of yourself only. Don't depend on me. I should give stick to warning. Such warnings will be more severe, remember, when I go to strength of materials onwards. When I enter structural engineering field, see, engineering mechanics is common. Even civil, mechanical or basic, somewhat physics only. When I enter structural engineering, I will give very stern warning. If people don't turn up to the class, this person is talking arrogantly. I am not talking arrogantly. I am talking the way a teacher should talk. Others should listen to him. Whatever he tells, they should follow. If they got confidence in me, I think you will have confidence in me, no problem. Okay. Number of members N, 6. Here also see, 1, 2, 3, 4, 5, 6. See, put a modified sketch here. See, this is not a member, no member here. Or, see, this sketch you modify, understood. See, modify it. There is no member here. So, 1, 2, 3, 4, 5, 6. Here, see. 1, 2, 3, 4, 5, 6 or 1, 2, 3. Modified now, okay, 6. Number of joint 5. 1, 2, 3, 4, 5. So 2j minus 3 equal to 2 into 5 minus 3 is 7. Therefore, see, number of joint is 6. Number of members are 6. Joint is 3. When n equal to 2j minus 3, it is called perfect frame. Perfect frame. But here, n is, see, not more, okay, less than 2j minus 3. Therefore, one member shortage. See, for perfect frame, you require what? 7 members, 2j minus 3. We have got only 6 members here. 1 member shortage. Therefore, common language, right here, if you go by basic definition of, see, what I told, where I wrote it, basic definition of n equal to 2j minus 3 is perfect frame, and n not equal to 2j minus 3 is imperfect. In imperfect, again I told n more than 2j minus 3 is, or n less, then n less than 2j minus 3 is deficient and also unstable. I told unstable. And if n is more than 2j minus 3 is redundant, and statically it becomes indeterminate. Statically indeterminate, internally it becomes internally indeterminate. This I told on that day. So as per this statement, as per the basic statement, looks like, or somebody will comment, it is what? Imperfect frame. Thereby further it is deficient frame. deficient frame, and therefore unstable. That will come to the mind. You write all this, but no. You should be careful. No. Because I will tell you one thing. In any pin-jointed frame, if a member is present, connected at both ends. See, these are all what I can tell is logical and thinkable factors, and connected at both ends to hinges, then axial force in that member is zero. There is no force. Reason I cannot tell, because there is no deformation for that member. See, in engineering mechanics, I can't discuss. See, when you go to stiffness method, axial force equal to K delta. K is the stiffness, AE by L, delta is the deformation. When there is no deformation, axial deformation for a member, there is no axial force, because if axial force is there, it will either shorten or elongate. Compression means shorten, tension means elongate. So when it is not present, force equal to zero. See, those who got a capacity, you understand. Zero. Therefore, we can, but condition. Someone may tomorrow comment to me, sir, it is not zero. I know it, keep quiet. Due to external loading, it is zero, remember. And there is a term called temperature effect. If there is a temperature change for any other member, still that member is zero. So force in that member will come only if there is temperature change for that member. Only if there is temperature change for that member. Then also it is not unknown force. Suppose if T is the change in temperature, if the temperature is increasing, member will be in compression. If temperature decreases, member will be tension. Then the axial force in the member equal to alpha T is the strain into E is the stress into area. Why? Do not bother. Or, see, if there is temperature change for other members, this member, if you provide a member here, has no effect. It is as good as not there. See, zero. Zero means what? See, zero means as good as not there. It is not there. Zero. Unless there is change in temperature for that member. Even then, it will not affect the other members. Force equal to alpha T into EA. Or there is a lack of it for that member, say delta. Delta is the lack of it. Then force in the member equal to AE by L into delta. For that, and because of that one, no force for other members. Lack of it of other members will not have effect on this member. Or if there is support settlement, suppose any support settles, then effect will be there. Therefore, and remember, so this member and other one will be separate. This is a separate group. This will tell, I am not with you. I am unique member. I am a unique member. If it is there, it will tell, I am a special member. I am not bothered about you. You do whatever you want, deform whatever you want, experience any change in temperature, experience any lack of it. Unless there is temperature change for me, or lack of it for me, or connecting support yields or displaces, unless it happens, I am zero force. If you want, you can consider me, I am there. So because of that reason, what you can do is, you can imagine, right here, you can imagine You write the statement. For this, both the frames here, you can imagine, but do not provide. Do not provide it. You can imagine there is a member with zero axial force connected to the two hinges. You imagine a member. See, that is red color I'll put here. Okay, no problem. Imagine I am there. But I am not participating. It is there, but remember, imagine, see, zero force. Put the sketches. Later I put one more sketch actually. Don't worry. This all you can take photograph if you want. Do not disturb original sketch. Take photograph of this one, then write. Therefore, you can call this frame as, now number of members will become 7. So, now will become 2j 3 also equals 7. So, it becomes perfect frame. So, this is internally, what happens now? Internally determinate. Actually, this is a very sensitive concept. I can talk hours together of this one, but sufficient. Now, one doubt comes. What about external? See, again doubt will come. See here. What about external? What about external? See, we already know. We know that for a, I am telling only once, for a hinged support, there are two independent reactions. Namely vertical and horizontal. Usually you take vertical, horizontal. You can take any direction. Okay, vertical and horizontal. Therefore, see here. Therefore, for both question number 20 and 27 or 18, not only these two questions, any question coming afterwards now, any question where two hinged supports are given with only one member connect. See, now I'll remove this one now. See, I'll remove this one now. Where two hinged supports are given with only one member connected to one of the hinges. Very important, right there. I put the condition. There, it looks like 4 reactions. Why? 2 each. I already told you, for a hinged support, there are 2 reactions. So, 2 reactions here, 2 reactions here. Or if I refer to question number 26, what are VA and HA, VB and HB? See here. I'll put red color now. Only one question sufficient. See. VA, HA, VB and HB. Random direction I am taking. VB and HB. Here if you want. See. I remove everything here. See. Question 27 I put here now. Question 27. Come this side. Okay. See here. VA, HA, VB, HB randomly. Okay, that's what it happens. Therefore, number of unknown reactions equal to 4. But number of basic conditions of static equilibrium is only 3. Which one? Sigma m equal to 0, sigma v equal to 0 and sigma h equal to 0. These are the 3 conditions. So, therefore, sudden feel, I am dictating, you should write. Therefore, suddenly to the mind, what comes is, unknowns are more than equation, it is statically indeterminate. the feeling will come indeterminate. Why? Unknowns, I told earlier, unknowns are more than number of equilibrium equations. It is indeterminate. So, therefore, what comes to mind is internal. Therefore, internal problem solved. Internal solved. Even if one member shortage is there, you can imagine a member there. Idle member. I will tell a member, you go there. I am not participating. You be there. For somebody who is counting, when they count, you be present. See, when they count number of members, you present. Once they finish counting and go home, you also go home. Okay, done. Agreed. So internally solved. But externally, it looks like indeterminate to first degree. First degree because this all will come later, don't worry. Those who want to understand the concept later, I am uploading a systematic way, I am explaining the degree of indeterminacy all. So 4 unknowns are there, only 3 equations, 1 shortage, indeterminate to first degree. No. Again, no. Because, see here, reason. Because at the hinged support, where only one member is connected, one member is present, there is only one reaction. Along that member. Because here, whatever is the axial force in the member coming here, this force, member force, same here only. That is what? Here, VB present, HB equal to 0. Here, see, HB present, VB equal to 0. Or common sense. See, again, common sense will do. Common sense, see. Anywhere you put a hinge here, that's all, no member. Apply, a member is there here. You apply a force here, member force, say P. If P is the member force, for equilibrium, just one reaction. See, P, reaction. Or, see here, this point. This is for this case, here. If this is the member, see, if this force is P, member force, then reaction is this way. Reaction equal to P. So at the hinged support, where only one member is there, there is only one reaction, which is inline, collinear, or you can write here along the member, or in simple language, only one reaction, which is collinear to member. Collinear to member there. Only one member is there. See, not here. Here 2 members are there. There no. Here 2 reactions will be there. Only one reaction is there. Therefore, now number of reactions becomes, number of independent reactions become 3. Why? 2 for other hinge, and only one for that hinge, to which only one member is connected. Therefore, now number of unknowns are now externally also number of unknowns is 3. Equilibrium condition also 3. Therefore, determinate. These things you have to remember. I did not explain too much because this is not the state to explain. These all should be explained in structural analysis. Somebody studying engineering mechanics for academic purpose or some competitive examination, they may not be able to digest this one. If somebody is interested in structural knowledge, he can understand, he or she can understand, or he or she will decide, okay, some specialist there. Later he will go, I am also attending his class, he should decide. I have decided to continue study from him up till whatever he teaches. I will tell frankly one thing. There are some students here, I don't want to tell anything. They will tell, sir, whichever course you conduct, I am coming, sir. You already came, second time, sir. They are coming repeatedly. One person actually came 3 times for the same subject. He knows everything. Why, sir, I want to come to your class, sir. Even if I know, sir, the coming to the class, I will listen from you once again. It will sharpen my brain, or it will give more knowledge to me. There are so many people are there. They will come. Whatever subject you are doing, I am coming. Not too many, few. Total I remember around at least some 10 members were there who keep on coming for every class I conduct. They will again join. I will tell you already came last time. Sir, once again. Sir, instead of wasting time somewhere, I feel this is the best way of what? Not spending time, utilizing the time, not spending the time. It is not time pass. Utilizing time, at least knowledge will improve. Therefore, those who want structural knowledge, do one thing. You write there. Later, he is going to indeterminate structure. Again, he is going to pin-jointed frame there. That time, your mind will, or your level will be much, much more. There, he will explain all this once again. There, I will understand. Okay. Others who are not coming there, leave it. So, because now I am giving you procedure. See, now see what most count is, now. Therefore, no important for everybody. Important for everybody. Everybody knows everybody. In the bracket, whether you are studying the subject for engineering mechanics for examination purpose of first semester or third semester BE in some colleges, or some foreign university, some other semester, or you are going for competitive examination where you require this one. And of course, also for those who want structural knowledge. Now, very important for everybody, what I will tell is, I will give this all you are right. Procedure for analysis of, okay, I write once again. Okay, I remove the full this one and write procedure. Next class I am solving this question, 1 minute. Before that I will take a photo of this one. Who will remember this one now? Okay, one photo I will take so that I can write the question once again. Next class I am solving both the question. I will follow the procedure. See, I am following my own procedure. Okay, not that way. What way I solve, I will give procedure for you. Okay, I write the procedure for you. I remove the full book. See, now it is important for everybody. Procedure for analysis of what? Pin-jointed plane frames with the 2 hinged support with the conditions. 1. Only one member connected to one of the hinges and no member connecting the 2 hinges. One note here. By chance, if a member given connecting to the 2 hinges only for engineering mechanics, consider 0 axial force for that member. That is, that member is as good as not there. You write there, but don't do this one. It is hinge and roller. No. 2 hinges, a member is connected, single member, either side connected. You write axial force is 0 there. So that member, you write, since the axial force is 0, that member is not considered. Or you consider and put 0 there. Okay. Okay, now, method of joints. Method of sections I will tell you later. At that time, all this I will not tell once again. I will tell once again, go back. See, no need of finding support reactions. Unless it is required, say in a competitive examination. So, method of joint is what? This is for what? That is for finding axial forces in all members. You write that way, purpose. I forgot to write. Method of joint is for finding axial forces in all members. If you do solve by method of joint, no need of finding support reactions unless it is required, say in a competitive examination. One more note here. Suppose you try to find, you cannot find. Why? Unless you know that special concept of single reaction for that hinge, you will consider two reactions. You cannot find. Unknowns are 4. So, no need of finding support reactions. Then, how to start, sir? Start analysis from other side. That is right here. Other side means, see, usually I am dictating now. Method of joint, you consider equilibrium of a joint having not more than 2 unknowns. Start from other side. See what I am doing. If the 2 hinges are on the left side, you start from right side. If the 2 hinges are on the right side, for you it is right, I am telling for you, you start from the left side. If the 2 hinges are at the bottom, start from top. If 2 hinges are at the top, start from bottom, other side. Start from other side. Do not, right here, do not even touch the 2 hinges. Tell goodbye. Well, I am going. Okay. Start analysis from the other side, class I am explaining, and get axial forces in all members. But remember, not for this question. This is hinge and roller. Here you have to find reaction. See, here reactions are required. Why? Because one hinge, one roller. Unless you find reaction, you can't start from anywhere. One hinge, one roller, you have to find the reactions, compulsory. 25 questions are over. This is a special case I am telling. 2 hinged support with only one member connected to a hinge and no member connecting the 2 hinges. Get axial forces in all members. Then, see, then, I dictate here, see, if the question is only to find axial forces, you write, our work is over, stop, go to next question, or go for tabulation. Right here, I am dictating. If the question is to find only axial forces, yes, we finished it, over, leave it. But if the question is find axial forces and also support reactions, then using that axial force calculated for the members connected to the hinges, you can find support reactions right there. He will explain in the class, in the example. I can't explain here now. Right here. Or suppose in an examination, say competitive examination, they ask reaction, no axial force required. Then you can't waste time. What you do is, then find support reaction like earlier, but that hinge where only one member is connected, you consider only one reaction which is collinear with the member. Okay, write all this note. I have dictated now. This is a procedure for method of joint. Sufficient. I do not want to make more complications. See, anyway, those who find difficulty can do one thing. Wait for next class. I am solving that question 26 and 27. Both are identical questions. So I am solving, then it will be fully clear for you. So, but this part is required. Earlier what I told is a logical part or theoretical part. That is for your choice. If you want, you can study. So I will tell once again, method of joint, start from other side. Right, once again right here. He told just now, method of joint, you start considering joints from other side. Then slowly come inside. When all members are over, stop, over. If the question is to find only axial forces. But by chance, if the question is find axial forces and also support reaction, some tricks are there. Using the axial forces calculated for those members connected to the hinges, you can find support reaction. But if the question is only to find support reaction, you can't waste time on axial forces. Then 1 marks question, then you find the reaction in the earlier way, but that hinge where only one member connected, only one reaction. How collinear with the member and enjoy. If any doubts are there, see solution of question 26 and 27, then again come back and study and understand. Furthermore questions I am solving. Then see 26, 27 are basic questions. Then 28, 29, 30 are same type of questions where I will not tell all the story. I write the question here and solve. Okay. That's all. So it's theory part. And actually I am going for native place. So another 2-3 days I have a difficulty. So what I am doing now, so that no class is missed, I am preparing classes now, little short duration. Because overnight I have to do it, early morning I have to leave. So for that purpose, I am preparing now. Okay. Now, I will start those questions in the next class. So next class I will tell, you should see at least procedure given in the last class. Okay, thank you. Next class we'll meet.